Okay, so focusing in on Chapter 5. Chapter 5 focuses mainly in on congruent triangles. So, today we're starting 5.1, Part 1. The stuff that we are doing in our notes today, guys, enough with the conversation and get back up in your assigned seat. The stuff that we are doing today should look, overall, familiar to you. Because you've talked about this stuff before. One of the things we're focusing in is on classifying triangles. Now, there's two ways to classify triangles. You can classify triangles by their sides, or you can classify them by their angles. Classifying them by their sides means taking a look at how many of the sides are congruent. If none of the sides are congruent, it's called scalene. If two of the sides are congruent, technically it's at least two, but we're just going to focus on if it's two, it's isosceles. If all three sides are congruent, it is equilateral. Do these terms sound familiar? They should from middle school. If they don't, it's not the end of the world. Hey, we just got them down again. We can also classify triangle by their angles. If all three of the angles are acute, it is an acute triangle. If there's a right angle in the triangle, you know this one. It's a right triangle. If one of the angles is obtuse, we call it an obtuse triangle. And the last one doesn't tend to get heard about a lot, and that's if all of the angles are the same. It doesn't tend to get heard about a lot because of the fact that it's got some things to it that it tends to get overlooked. First off, if all of the angles are the same, they're all going to be acute angles, and so people tend to think of it as acute, but it's not acute. Also, if all of the three angles are the same, one of the things we're going to learn in this chapter is if angles are the same in a triangle, you also have some side lengths that are the same. And so people tend to overlook congruent angles for the congruent sides. But there is a separate term for it, and it's called equiangular. Every single triangle that is equilateral is also equiangular and vice versa. These will always go together. So, one of the things you're going to be asked to do is to classify the triangle by both its sides and its angles. So, I'm going to start off with that one. I'm going to start with classifying by sides. How many congruent sides does this triangle have? 3, and if it has 3 congruent sides, what do we call it? Equilateral. Also want to classify by angles. What do you notice about its angles? They're also all congruent, and if it has 3 congruent angles, it is equiangular. And again, if you see one of these two words, the other one goes with it. If it is equilateral, even if they didn't have the angles marked, if you knew the sides were the same, you can also assume the angles are the same. Okay. Question B. How many sides are congruent in this triangle? None of them. 1 tick mark, 2 tick marks, 3 tick marks, indicating they're all different. No congruent sides? Scalene. Angles. There's a right angle, therefore it is a right triangle. Please do put the little triangle symbol after it. Differentiates between angles and triangles. By the way, you don't have to put the S or the A for sides and angles. I just do it just to help us clarify. Okay, C. Classify it by sides. What would you tell me? It is isosceles. It's got 2 congruent sides. What about by angles? It is acute. How do you know it's an acute triangle without anything actually being labeled in the corners that tells you that they're all less than 90?
Is it those lines that are on the triangle?
Nope.
You can just tell.
I've got 2 sides that are congruent. I've got 2 angles that are congruent.
And then you got the tip that's smaller than the two sides.
True.
Does it have like a version of the long symbol also?
True.
It's also not a two circles line long line.
Measure.
It's very tiny.
The key thing is acute angles look like they're smaller than 90. They're closer together than 90. Obtuse angles should look wider. Okay. Last one on this page. By sides it is isosceles. By angles it is obtuse. Now, before I move on from this page, I just want to make a quick note about something. Because one thing tends to be overlooked a little bit when it comes to the classifying by angles. Generally speaking, when classifying by angles, you can kind of get a look at the picture and you can kind of tell if it's acute or if it's obtuse. But by looking at a picture like this, kind of looks like a right triangle, right? But can you tell if it's a right triangle?
No, because it doesn't have the little square in the corner.
Correct. Now, I'm not going to give you one like this, purely like this, without giving you some way of figuring out if that's a right angle or not. I could do something like have it vertical to a right angle. I could have it a linear pair to a right angle. Or what's on the next page is another way that I can tell you if that's a right angle or not. Another way you can tell if that is a right angle or not is using the triangle angle sum theorem. Triangle angle sum theorem says that the angles inside of a triangle must add up to 180 degrees. So, if this is my triangle, the measure of angle A plus the measure of angle B plus the measure of angle C has to be 180 degrees. Have we talked about things adding up to 180 before?
Yes.
Yes. What term typically goes with that? Supplementary. Are the angles of a triangle supplementary? This is something that people tend to mix up a little bit. Be careful with the term supplementary. If I pull up the definition of supplementary. It says angle ABC and angle XYZ are supplementary. How many angles are in that? 2. Supplementary is defined to be 2 angles that add up to 180. Is it possible for triangles' angles to be supplementary? No, because how many angles are in a triangle? 3. And if all 3 of them have to add up to 180, then it is impossible for 2 of them to add up to 180. So, one thing I can do to give an indication on something like this being a right triangle is I could do something like this. I could tell you that this angle is 60. And this angle is 31 degrees. If the 3 of them have to add up to 180, what's this angle? You could put an X there. And all 3 of them have to add up to 180, so I could write the equation. What would it look like? 60 plus 31 plus X equals 180. Hint, X will be equal to 89. What kind of triangle is this? No. Acute, because all of those angles are less than 90 degrees. So be careful about ones that look like a right triangle. Can you tell by looking at an angle if it's obtuse or acute? Yes. Unless it's really, really close to 90, then you need a little more info. Anyway, back to the actual note packet. Find the measure of the missing angle and classify the triangle by its angles. Okay. I got 60, I got 35, I got X. It's almost like the thing I did on the board was like purposeful or something. X plus the 35 plus the 60 equals the 180. If I want to solve that equation, what should I do first? Find your like terms. X plus 95 equals 180. Subtract 95, X is 85. Solve for the missing angle. Missing angle is 85 degrees. What type of triangle is this? It's acute. Do we have enough information to tell if it's scalene or equilateral or equiangular? Sorry, isosceles is what I meant to say? Not really, but can you kind of tell if there's any congruent sides on this one? Yeah. Some you might not be able to tell, and generally speaking, when it comes to the sides, I'm going to give you some sort of indication on if they're the same. Either the tick marks, or I'll label 2 sides with a length of 5. If they both have a length of 5, doesn't that mean they're congruent? Okay. Okay. I want to solve for X. What's the equation look like? Add up 3 angles, they add up to 180. Combine like terms. That's 157 plus X equals 180. Subtract the 157. X is 23. What kind of triangle is this? Obtuse. The angle I found might have been acute, but in the end, there was still an obtuse angle there. You would do the same thing on question C. I'm going to skip C. Because do you get the general idea of these lines? They can get a little more complex. Like the ones below. That say solve for X, and now the angles are a little more complicated. But it's still 3 angles in a triangle. And the 3 angles in a triangle will always add up to 180. Which means I can still do the same idea. What are the 3 angles?
35
Exactly. Do not forget the 90. For some reason, because of the fact that the 90-degree angle is not written as a number, some people tend to skip over it. 35 plus 58 plus 90. Combining like terms, aka simplifying, is 183. Subtract, and x is -3. Are these ones really any different than what I was doing already? No. I'm gonna skip over B, we're gonna go over to C. What am I writing?
75 plus 7x minus 7 plus 35 equals.
Why is it okay to write this without the parentheses?
Because it's just holding the degree.
Because the parenthesis was only holding on to the degree symbol. When I combine like terms, what do you think is the most common mistake people make on this problem? They ignore the fact that the 7 is negative. So be careful of that. 75 plus a -7, aka -7, plus 35. Seven x plus 103 is equal to 180. Now what? Subtract the 103. 7x equals 77. Divide by 7 and x is 11. Still pretty easy? Okay. Got to change in instructions again. Last question says find the measure of the indicated angle. And then it gives us an angle BAC, or on this one, angle ACB. Thoughts? I could do the same thing. It would solve for x, and then how do I find the measure of the angle? Plug it back in. So I start the same way. X plus 37 plus x plus 79 plus 46. Make sure you get all three angles. Equals 180. X plus x. 2x. 37 plus 79 plus 46. I don't know that. I got a calculator for a reason. 162. Subtract the 162. 2x is equal to 18. Divide by 2 and x is 9. But remember, is that our final answer? No, I gotta plug it back in. Which angle is angle BAC?
X plus 37.
Remember, the middle letter is the vertex. Angle BAC is angle A. When I plug back in to the x plus 37, I get 9 plus 37, which is 46. Notationally, what should I be writing though? Measure angle BAC equals 46. Technically, you should have the degree symbol. Is at the end of the world if you don't. No. Try the last one on your own.